Hello, everyone. Welcome back for the last session of the day here. And we're culminating with a really great session here by Yanick. Yanick is from EA, and he's going to come up and talk about how they've built their mobile game servers on Google App Engine. So really practical use of a lot of the things that you've learned today, and he's going to give you some tips and tricks as well. So welcome, Yanick.
Thank you, Ryan. So hello, my name is Yanick Belanger. I'm architecture lead, server architecture lead at Electronic Arts, specifically at the Playing Mantis studio up there in Montreal. If you want to know, yes, we still have that much snow up there in Canada. So I'm here today to talk about how we integrate Google App Engine in our development of our mobile game servers. Okay. I'm not a sales guy. I'm not here to promote App Engine. I'm not here to promote our games as well. I'm simply here because we believe in my team that Google App Engine is really an amazing piece of technology. So let's jump first on a really quick scenario, okay? Let's say you're a small game company. You developed an amazing new games, okay? It's going to be awesome. This game is a multiplayer game. You have your server ready. It sits right under your desk using this old Pentium that was laying around, okay? And you launch the game finally. It's a great game. It gets immediate success. It's a viral game. Everybody talks about it. You get a major response from the market. But eventually, what you see is that your old machine is smoking badly, and you get capacity issue. So how can you prevent that? Okay, you have to plan for success, and typically using a standard technology stack on the server side, it means that you have to invest a lot of money and time and resources in proving that your platform will stay alive in the event of a successful game. That's where Google App Engine makes sense. Okay, it makes sense for small companies, and it also makes sense for big companies like EA. So what's App Engine exactly? Okay, I'm not here to describe in details what's App Engine. I mean, during the previous sessions, we had a pretty good overview of what's App Engine. There's tons of good resources on the internet, good videos that describes what's App Engine. But let's see a quick overview of what is this platform exactly. It's a platform as a service cloud computing. It means that your application will sit on top of a very high-level platform. It's pretty different than a IaaS infrastructure as a service platform where you basically have to manage your OS, your software stack. App Engine, as I said, is a high-level platform. You have no infrastructure to manage. You can build your application using Java, Python, or Go. It's built using existing Google's technology and Google services. Okay, it's the same type of technology that's used for their search engine, for example. It's also automatically scalable. It's an auto-scaling system, which means they will allocate new instances for you as your traffic goes up and deallocate those when the traffic goes down. So at the end, you pay for what you use. At EA, we use App Engine to develop mobile connected games. They all have a pretty strong integration with social networks. Most of them are asynchronous turn-based games, so multiplayer games, but we also have single-player games. We use other solutions for two types of game. Okay, real-time is kind of hard to achieve on App Engine because it's a shared infrastructure with thousands of other applications. To have a predictable timing on App Engine is pretty hard. Okay. So we have a different solution for that. For casino-like games, this is pretty interesting because for casino game, you need a really quick a quick synchronization with your server, okay? And that's currently not possible from App Engine because they don't support a dedicated channel between mobile client and your server. They have a pretty good technology. They're a channel service for web clients, but there's nothing for mobile clients yet. It doesn't mean you can't use an hybrid solution where you would host all the non-real-time aspect of your game on App Engine to manage profile, manage matchmaking, you manage your microtransactions, and have a separate system hosted, for example, on Compute Engine or your in-house system for the real-time aspect of the game. Delivering high quality, that's such an interesting topic. I mean, App Engine is really an easy platform to work with. You can quickly code and deploy in a matter of minutes an application on App Engine, and like that, it's available on the internet. It will scale. It's all great. That being said, don't expect to code quickly something on App Engine and expect your application to have a great quality. Okay, you have to have best practices, technical knowledge of the platform. You have to adopt agile processes. So I'll give you a quick overview of our approach to achieve high quality servers on App Engine and how we leverage the platform strength to do it. First, this is really important. This is not something everybody understand at first, but we need to keep everything as simple as possible. App Engine itself is pretty simple to use. They have a simple API. So we need to keep everything pretty simple. Why? Well, first, by keeping your implementations and your design simple, you get a more consistent quality. You get a platform, an application, that is easier to learn for the new developers. You get a platform that is easier to refactor. Okay? For example, we don't add useless abstractions on top of App Engine. We connect directly to their API. If there's no real goal, real benefit of adding an abstraction, we don't do it. These are the basic principles of agile software development. App Engine offers a great API, so why should we add an abstraction on top of it if we don't need to? Okay, we don't over-engineer our solutions. We code for the requirement we have today, not for the requirements we're going to have next week. Okay, and we try to keep the design as simple as possible so we can refactor the design next week when we have new requirements. We also leverage a lot of third-party libraries. There are tons of them out there. We use Java for our game servers, and there are really great third parties like Google Juice for dependency injection, Jersey for your RESTful API, Mockito for the unit test. Those are all well-tested, proven libraries that you should use. If you start coding something that is there to solve a common problem, you're probably wrong. There are tons of existing libraries out there. Use them. We don't reinvent the wheel, basically. We also reuse components within the company. Okay, there's no goal to recode the same low-level stuff every time. So we have what we call our toolkit library, App Engine toolkit library, where you can find basically a set of reusable components, reusable building blocks. They're all optional building blocks. It's not a framework. It's pretty different. And that's where we share across all our games the common stuff to handle matchmaking, for example, microtransaction validations, connection to external services. Another approach we have is this principle, test early and test often. Okay, the idea is that the cost of finding a bug is exponential as your development process is going forward. I mean, the best place to find a bug, this is not really a test phase, but it's a great place to find a bug is in your compiler, directly in your editor. You see right away when there's an issue with the call you're doing. You fix it, it takes 5 seconds. The investment is like minimal, okay? You don't lose your time, it's fixed. We do unit testing. This is a great place also to find your bugs and regression bugs also. We do unit tests to test in isolation our components. App Engine offers a great set of stubs for their services that will help you a lot to develop your unit test. We also do integration test. Integration test is basically you want to validate that the integration of your different components is as expected. Okay, you want to test the glue between those components, basically. We also use integration tests as a kind of black box testing where we inject traffic just like a real client would do, and we validate the result. App Engine offers a great local development environment for that, where you can start easily on your development machine, a server that will mimic pretty well what you end up having on a real cloud. So what we have, using Maven for Java, we have a process that will compile the server, execute the unit test, start the server, execute the integration test, and validate that everything is okay. And these steps takes less than 2 or 3 minutes usually. It's really, this aspect is very important. It has to be fast so that your developer will run them every time. Okay, you want to validate the quality every time. You want to test often, basically. And the last place you can find your bug before they reach the players is in the QA team. But this is costly. Basically, you lose a lot of time. It's a lot of money, a lot of time when you find bugs there. It's preferable to find them in the previous steps. We also have a typical continuous integration environment that will build our servers and test them on every commit in our source control system. The build system will also automatically deploy our new versions on the App Engine environment on the cloud. And on some of those environments, we even switch on automatically the new version so that another team can start testing right away with the new version. We also have a dedicated team at EA that is specialized in doing load test, system test. Okay? Even though App Engine is an auto-scaling system, you still have to prove that your application will scale well on App Engine, that it will perform well at a reasonable cost. So, in summary, our approach to achieve high quality on App Engine is not rocket science. I mean, we use basic agile software development principles. We try to keep everything as simple as possible. We leverage the tools we have in App Engine to test, to launch a local environment. And most of all, App Engine is really a key component in achieving high quality. It basically handles all the hard stuff for you. It also gives you a great SDK with a great documentation, nice tools. So that's pretty neat. You know, App Engine is a very different platform. It has some particularities. It will generally scale and perform well as long as your application doesn't prevent it to do so. So we've learned over the past 2 years some strategies and good practices that I'd like to share with you today. Those are not, by the way, like the absolute rules from God for implementing stuff on App Engine, but it's coming from real games that are currently on the market. It works well. So first of all, by building your application on App Engine, you leverage a lot of Google's own technology. And to make it work correctly, your application has to fit the Google philosophy. They call it the googly way or googly way, depends on the reference. The general goal with the googly way is to have fast and small requests. The idea is that the latency or the response time is a good indicator of the amount of resource you're using in your request. So higher response time usually means higher cost. There are some tricks to improve the response time on App Engine. I will cover them in the next few sections. Your application has to be designed also to run on a distributed environment. But this is really an abstract concept. What does it mean exactly to design an application to run on a distributed environment? Well, App Engine offers an API that is an entry point to their distributed data infrastructure. Okay, an entry point to distribute your data and your processing. So you have to use them wisely. That's pretty much it on App Engine. Okay, that's what it means to design for distributed environments. So I like the idea of having an isolated silo per user, okay, an isolated data and processing silo. You keep every user as independent as possible. So that way, the App Engine runtime will distribute them in their data centers. In practice, though, it's almost impossible to have well-isolated users, okay? You have things like game, for example. In a multiplayer game, a game is shared between 2 users. So it's not a real contention point, but you still have to handle the concurrency, okay? A more extreme contention point would be a matchmaking queue, okay? This is really tricky to implement. It's a contention point because everybody wants to enter this queue. So you have to manage that with care, okay? There are strategies to handle contention points. I will give you some examples in the next slides. Something else we've learned is that NoSQL is really different than SQL. Okay, we use the data store to store pretty much all our data. The data store on App Engine is a NoSQL schemaless persistent storage. It's all managed by Google. It's pretty cool. Okay? You don't have to worry about sharding or redundancies and backups. It may look similar to your normal relational database, but there are fundamental differences that requires a major shift in the way you design your storage. One of the most common mistakes that a new developer with NoSQL will do is to try to normalize its data, just like it would do with a normal SQL system. This is a mistake because on App Engine, with the data store, you want to minimize the number of operations. These operations are costly and longer than in your typical SQL system, and you want to handle them with care. So by denormalizing your data structure, you can achieve some pretty good optimizations. By denormalizing, I mean to regroup and even sometimes to duplicate your data. I'll give you an example, okay? Let's take all the data that is related to a player. You have its profile, you have some stats, you have its purchases. In our game, we regroup them, all those data, in one entity. Okay, it's called a player. So that way we can optimize a lot the operations we do with the data store. You also have to adapt your data model for the use cases. I'll show you some real-world use case later in this presentation. The way you access your data is also quite different. You're limited, okay? For example, with queries, you can do a join operation. You cannot do a query on a non-index operation. It limits a lot what you can do. And you even have to modify your data model sometimes to execute a query. So that's a hard constraint, but it's there for the ultimate goal to reach high scalability and high reliability. Also, what's the most important things I think about the data store is that your developers must understand very well how it works, okay? You must read about the data store. You must understand everything about like the ancestors, the eventually consistent queries, the hot tablet issues you can get that will compromise your scalability. You have to understand all that because the data store is going to be probably the most used service in your application, and it will drive by itself probably half of the cost of your running instances. I was talking about great third parties. There are great third parties to manipulate the data store. For Java, it's called Objectifier. For Python, it's called NDB. Those are higher level APIs that will handle stuff like object mapping, transaction management, caching, auto retries. They are great, great tools. They will save you a lot of lines of code. And let's code these less bugs. Caching, well, for the last few slides, I've talked a lot about how to lower the number of operations you do, okay? A good way to achieve that is to avoid reaching the costly resources. And caching is a good way to avoid that, okay? It will lower your cost at the end if you use caching wisely. There are different techniques to cache, okay, in different layers. First, I'll talk about in-memory caching. This is very limited, okay, because keep in mind that you have multiple instances running that host your applications. In-memory caching is not distributed across those instances, so it's very limited. I'll give you an example of what kind of caching we do in memory. Let's say you have within your application 2 components at different time during a request that access a user profile. Usually because they're well isolated and well encapsulated, they don't talk to each other. So one component will fetch the user profile once, and eventually in your process, in the same request, you fetch through the other components the same user profile. So by adding a layer, an in-memory caching layer, you prevent paying the cost for the second access. But you have to be careful. Okay, it's very limited. The ultimate caching tool in App Engine is Memcache. Memcache is a low latency distributed caching system. And best of all, it's free on App Engine. It's totally free. But it doesn't mean you have to cache everything, okay? You have to be careful because the space is limited and you have to cache only the most used resources. Things that we cache in Memcache, well, pretty much all our persisted data is cached. Let's say if you fetch your list of friends from your favorite social network, we cache this information usually. Another layer where you could cache is by leveraging the edge cache on Google's infrastructure. By using the proper HTTP cache control header in your response, you can enable this caching in the Google front-end infrastructure. So that way, your next request will hit the cache instead of going to your application. So you save a lot of operations there. And finally, probably the most effective place to cache is on the client side. This is not well implemented in most of the games I've seen so far, but it's very efficient. When you do it correctly, there are known and well-defined HTTP caching mechanism for client-side caching with headers like if not much and if modified since. Those will greatly reduce your operations on the server side. We've also adopted other techniques to optimize our games. First, we try to reduce our instance startup time as much as possible. This is especially a problem with Java application because the startup time is quite higher than the Python applications. The idea is that App Engine will allocate new instances when your traffic goes up. So if you take a long time to start your instances, you prevent App Engine from scaling automatically and efficiently. I'll give you an example, okay? In one of our projects, we had a marketing campaign sent through push notifications to all our users. And within 2 minutes, the traffic jumped from the normal rate to 30 times the normal rate. Something that would be almost impossible to handle with a traditional system. Our application wasn't fully optimized for a startup time, and we had some issues, user impacting issues for a few minutes. But eventually, App Engine managed to ramp up efficiently. We also use AppStats for profiling. AppStats is a nice tool that is provided with their SDK. It will show you the resource you use within your request. So it helps a lot if you want to target your optimization. We use other techniques for parallelism as well. All kind of parallelism, like just multi-thread. Sometimes you want to spawn a new thread in your request and do some job in background. We leverage the asynchronous API for the data store and Memcache. We also use the batch operations for Memcache in the data store. We use batch process in our background task as much as possible. Those won't save you money, okay? They will just lower the response time, basically. So, in the next section, I will cover some typical feature we have in our game. Okay, some typical feature, not all of them. Games are pretty complex these days, and I'll show you how we implement them using App Engine. There may be other implementation strategies. It's up to you to decide if they're appropriate or not. Okay, first, the easiest feature, your profiling game state persistence. It looks pretty simple, okay? You just call the data store API, you store your data, and that's it. Problem solved. But not so fast. You have to be careful with the design of your persistence. As I said, you have to denormalize your data to optimize the operations and lower your cost. And you have to design the persistence by looking at the use case. Okay, let's take the profile, for example. Well, profile is pretty simple. Okay, you have as much read operation and write operations. There's nothing special about it. But the game state is different. In some of our games, the game state has a lot of read operations and very few write operations. The reason is pretty simple. We use, because we don't have a dedicated channel to update the client on the game state, we use polling, mainly in the main screen of our games, where we see all the active games. We have polling requests coming in every 10 seconds, executing a query to have the list of active games. So this is a lot of costly read operations. Okay, you have to execute a query plus a fetch for all your games. So we've adapted in some of our games a technique called materialized views, where you basically store the result of a query concretely in your data store. Okay, and you update this table on every update on the game state. So what you end up having is really an entity that contains the result that is expected to display the list of active game. And it optimizes a lot the number of operations required. Those two examples are not really doesn't represent really a contention point. Okay, there's no right contentions with them. But you still have to manage the optimistic concurrency nature of the data store. Okay, you have to retry. Even though if you use Objectify or NDB, they will handle that for you automatically. Social connectivity. Well, pretty much all the games these days have social integration. Everybody wants to play against their friends. It's all cool. It's not that complex to implement. We use the URL fetch service and Memcache cache some resources. For example, a typical call to your favorite social network will take maybe a few hundred milliseconds. It has an impact on the response time. It has an impact on the user experience. It has an impact on your cost. So we use Memcache to cache for X minutes the list of friends, for example. There's also a safety quota on App Engine for URL fetch operations. There are quotas, by the way, for pretty much all operations, but the first one you will hit is probably the URL fetch. And Memcache helps a lot with that, so you lower your number of fetch operations. Next feature, mobile push notification. Mobile push notifications are a complex beast to integrate in your application. Basically, because there are a lot of particularities with all the different mobile platforms out there. It's not easy to implement, and you have to keep in mind that there are third-party services out there that offers a higher level, like a kind of aggregated view, okay, that will help you a lot implementing push notifications. Those third-party services are costly, though, so you have to choose. Either you pay the cost of implementing or the cost of using those third-party services. In our case, since we have multiple games, we've decided to connect directly to the mobile platforms. We use background task for that. Okay, this is a perfect example of something you can do in background. You don't depend on the status of those push notifications, and background tasks are really good because they will retry automatically for you if they're configured to do so. For Android and Amazon, we use the URL fetch service to do an HTTP call to their service. For iOS, it's a different story. Okay, iOS use a custom protocol on top of TCP, and unfortunately, currently we have no official support for a socket connection from an App Engine instance. So we have in EA an in-house system that will handle that for you. Okay, so our App Engine application communicates through HTTP to this system that will push notification on the socket protocol. We are testing the new experimental socket support in App Engine, and currently it works pretty well. We plan to have our next game using this socket implementation directly instead of going through a different system. Client assets, there are graphics, there are sounds, there are client configurations, all kind of resources that your mobile client needs at startup. We usually serve them directly from our App Engine application. There are different solutions for that, okay? You can use Google Cloud Storage, which is a different system. It's not directly related to App Engine, but you can access your data from App Engine. It's more appropriate for bigger assets. Okay, it can handle pretty much any size you want. Another solution would be to package these assets directly in your App Engine applications. You have to mark them as being public in your descriptor file. So that way, App Engine will distribute them automatically to their content delivery network. So you get an excellent response time anywhere in the world. Matchmaking, this is a beast, really. It's not easy to implement matchmaking. Matchmaking is the process of matching two or more random players together. It's the perfect contention point. Okay, everybody wants to write in the matchmaking queue. We have different techniques to implement that. First, the most used technique we have is a component from our toolkit named the matchmaking service that is implemented using Memcache. Okay, you can use Memcache as a short-lived storage. It's not reliable, but it works well enough for matchmaking. Because it's not reliable, we have a fallback mechanism that is less optimal, but it still works. And we also have to implement an auto-sharding system on Memcache because even though Memcache is really fast, you still get some contention issues as the traffic goes up. You can also use backend instances on App Engine to implement the matchmaking queue. Backend instances are a kind of instance that is stateful and long-lived. The problem, though, is they're not auto-scaling, so you have to manage them by yourself. But it's a very good place to store the matchmaking queue directly in memory. There could be a third solution for if you don't plan for success. Okay, you could store directly the matchmaking queue in the data store, but the contention is really an issue with the data store. You can probably write on a given data store entity maybe twice per second. It's really an issue. Okay, but if you don't plan for success, you could do it. It works well. Microtransaction validation, it's a standard feature now in most of the mobile games. In-app billing is a reality. We have to implement it. The game server is the authority for everything related to transactions. For security reason, we have to validate the receipt on the server side and before we apply the result to the user profile. There are tons and tons of hacked requests coming from, for example, jailbreaking iOS device. For Android, it's only a matter of validating a signature using a certificate, so it's all done directly in the instance. For Amazon and Apple, you have to do an HTTP call to their system to validate the transaction, validate the receipt. And last feature, this is not directly related to your gameplay, but it's an important tool to optimize your game balance, to optimize your retention, optimize your profitability. It's a business intelligence. Okay, you need metrics to know what's going on in your server. Your analyst will basically need a broad range of data to do extraction and do aggregation and extraction to have the meaningful numbers. We have, for example, a matrix for the average number of games per player. Okay, the sales number per region. These are valid metrics. We have two strategies for those metrics currently. First is to execute a map reduce directly in the App Engine application. This is not optimal. Okay, it's limited because it requires a code change every time you want to extract a new metric. It's not really useful. We are testing a new solution to dump the data, the meaningful events on BigQuery, and give our analysts access to the BigQuery environment so they can extract pretty much anything they like. So let's now introduce a major buzzword in this presentation. Let's talk about DevOps. Okay, everybody wants to talk about DevOps these days. So let's get back to the initial scenario. Okay, you're a small company. You've developed your game. It's going to be amazing. The server's been implemented on App Engine this time, so it's better. Your game is bug-free. It's been load tested up to gazillions of players. It works well. But there's still something missing before launching the game. What's going to be your support model? Okay. The good news is Google's site reliability engineers monitor the platform for you. Okay, so most of the platform is monitored by Google themselves. All you have to monitor is really the interaction in your thin layer that is your application. Your application is really just a thin layer on top of the platform, a thin stateless layer. So what could go wrong with this layer? Well, things can go wrong in this layer sometimes. So in this context, okay, where Google's monitor the system for you, does it still make sense to use a standard multi-tiered support model? In our team, we don't think so. Okay, we're in a transition to adopt a full DevOps model, and there are a few reasons for that. First, the support team is kind of redundant. Okay, let's take a typical scenario where the system fails. Okay, the support team currently see that there's an issue with the system. Okay, there are some metrics that are wrong, and so there's nothing they can do, basically. They cannot reboot the servers. They cannot execute a job on the database. So every time they end up calling us and asking us, what's going on? What can we do with that? On our side, most of the time, there's nothing we can do neither. Okay, we look at the Google App Engine status page. We see there's an issue currently with the platform. Google is already working on it. There's not much we can do. We wait, okay? Often in a matter of minutes, it's resolved and everybody's happy. So there was a pretty cool picture that one of our managers took during one of our downtime where we were sitting on couches playing NHL 2013 while the server was down. And everybody was like, what are they doing? The server is down currently, but there's nothing we can do, okay? Google's working on it, no problem. Another reason why we will adopt a DevOps model is we're already pretty much responsible for all the operation steps. Okay, we deploy our application ourselves. We manage our application or our App Engine environments ourselves. We handle pretty much every aspect of operations. We have short development cycles. We deploy every week. So we're very close to have a real DevOps model. The only thing that is shaky is the support from the support team that we want to remove. And if there's an intervention to do, only us the developer can do it, because your system is really your code with App Engine. So only the developer understands well the dynamics of the code and can fix the problem. So you need your developer anyway. The only thing missing with App Engine is a proper monitoring tool for your application layer, okay? They don't prevent you from developing your own system, and that's what we've done with at EA. We have a basic metric libraries that we use to increase counters, okay? Those counters get transferred periodically to a third-party system, monitoring system, where we can set thresholds and alarms, okay? And we get notified when something is wrong. So that's close to be in production. We're still using the legacy support model, but we're moving to this system. And, well, that's pretty much it already. Well, to summarize this presentation, okay, we're really pleased with App Engine in our game development. Okay, it's been really a great story. We've been using it for 2 years now. We've learned a lot. I think we achieve good qualities with our systems because of App Engine. Okay, when it's been released like 4 years ago, App Engine, in my opinion, was a game changer. It was really a right step in the right directions. It enables you to focus your work on your game. Okay, we are game developers. We are not specialists, infrastructure specialists. So you can focus on your what you do best. Okay, so it's a great system. I recommend really everybody to use it. So, thank you. Do you have any questions?
Hi.
Hi.
One quick question. Why did you choose to use Java to do all of your App Engine programming as opposed to one of the other languages?
That's an interesting question. Well, we had good Java developers in our team. Nobody knew Python really well. Go was a new language. It would have been cool to use Go, but we decided to go with Java because everybody knew Java pretty well. Actually, beside the startup, the increased startup time on App Engine, Java works pretty well. No other questions? Well, that's it. Thank you, guys.
And on behalf of Google, I would like to thank everyone for coming out here today. Hopefully you all learned something and are going to build your next game on the Google Cloud Platform. We're going to be around. Feel free to ask us any questions that you have or reach out to us online using the contact info that you've seen today. Thanks again.
2, 2, 2. Yeah, check. 1, 2, 2.